Hello class, welcome to today's lesson, and today I will briefly go over the four application problems in the portfolio, which are problems 12, 13, and 14 and 15. Am I gonna solve them completely? No, I don't want to bore you with that stuff. What I'm gonna do for you is basically set the equations that will solve each of these problems, okay? And that's actually the difficult part to do, the setting up of the equations. Then solving the equation is something that should be already kind of like a mechanical process already. Okay, so that's what I'm gonna do for you. I'm gonna more or less help you out uh, with the reasoning of the problem, and then you will solve it. You will finish it on your own. In case you have not solved them, I believe most of you have solved these ones already. So let's start with number 12. Number 12 says the following. We have the difference between two positive whole numbers is 6 units, and the sum of their squares is 218. What are these numbers? Okay, as I've always told you, label your numbers, okay? I'm gonna say that A is my first number, the first of these two numbers, and I'm gonna say that B is my second number. You can choose other letter or other variables if you want. And then I'm gonna start translating this language into mathematical equations. The difference between these numbers is 6 units. So I can write this. And it doesn't matter which one you write first. It doesn't make any difference. Let's label this equation as equation 1. And then the sum of their squares is 218. So we're gonna write this. This is the second equation, okay? What are these numbers? Well, with these two equations, apparently I can solve this problem. Let's see. We have two equations. Then what I can do is, as you may remember, when you have two equations, is a substitution method. You can start by isolating one of the variables. In this case, I'm going to isolate a from this equation, and I'm going to have this. Okay, this is from equation 1. And next, I'm going to input this value into the other equation. So a equals 6 plus b. That means that if I use this equation, I can write the following. 6 plus b squared plus b squared equals 218. And as you can see in here, we have a quadratic equation. You can expand this binomial. Let's do that very quickly. That's going to be 36 plus 12b plus b squared plus b squared equals 218. And this is a quadratic equation which is not yet in standard form. You have to solve it. By solving it, you will find b. Okay, and once you have b, you can put it here and find a. And therefore, we have already solved this problem. You see, this is the difficult part, the analysis. The solving of the equations is merely mechanical. Let's continue. Problem 13. It says the sides of a rectangular land are given by the expressions x minus 5 and x minus 7 meters. So let's right away draw some diagram representing the problem. So we have x minus 5 and x minus 7. Again, which one is which? It doesn't make any difference, okay? It doesn't make any difference. Determine an algebraic expression that represents its area. Okay, that's easy. The area of any rectangle is one of the sides times the other. There you go. So this is the first, this is the answer for the first question. And then they tell me, once the expression has been obtained, what are the measurements of the land so that the area is this much, 1,760 square meters? And what is the perimeter of the land? So basically, they're telling me that this whole area should be this much. Okay, and if I know that this area should be that much, then all I can do is grab this number, put it here, like so, and that's it. Okay, what is this? This is a quadratic equation. How do I know? Well, even though it doesn't have any square right now, if we multiply these two binomials, what am I gonna get? X squared minus 12x plus 35. And as you can see, we have another quadratic equation, which we can solve by whatever method you want. It doesn't make any difference. And by solving this quadratic equation, we will get x. Now, what is x? X is neither of these sides. X is just a value, okay? It's just a variable. Once we know x, we can put it here and put it here. And by doing this, we can find the length, well, the the length of this side and the length of this side, okay? And that solves this part. What are the measurements? And now what is the perimeter of the land? You're just gonna have to add all the four sides. That's about it. Let's move on. Number 14 goes like this. The base of a triangle is 5 meters greater than the height. So let's draw any random triangle. Oops. Okay, so from our perspective, this is the base, and the height would be the distance from this vertex to the base perpendicularly. Okay, this segment and this segment are perpendicular in order for this to be the height. So what do we know? We know that this, which is the base, is 5 meters greater than the height. So if I say that this is the height, this, that makes this, all of this equals to h plus 5, according to this sentence. The base of the triangle is 5 meters greater than the height. And then they tell me if the area of the triangle is 102 meters squared, what are the dimensions of the base and the height? So we know that the area of a triangle is calculated by base times height over 2. That's something we know from elementary school. And thus, what I can do is put this in here. What is b? B is h plus 5, according to this diagram. H, I can just keep it that way, over 2. Okay? And then they tell me if the area of the triangle is 102 square meters. So one more time, I need to substitute that value in the area, like so. Okay? One more time, this doesn't look like a quadratic equation, but once you arrange it in certain way, we can find this. We multiply these two factors. There you go. This is one more time another quadratic equation. The variable is h, and I need to solve it in order to find h, which is the height, right? Okay. And once I know the height, I can know the base because I can put the height in there. It's very simple. Uh, you may be thinking, well, teacher, you always tell us to write the the meaning of the variables, like h is the height of the triangle, b is the base of the triangle. And yeah, I'm being like quite short in my explanations in this time, but you know that you have to do this, okay? Or at least give a diagram like I'm doing by writing this, by drawing this diagram and representing these segments in this way. I'm actually saying the same thing as with words, okay, more or less. So I'm not being too vague. Okay, so we're done. You see how simple it is? These problems are solved in 2 minutes each. It's extremely simple, at least these ones. 15. And last one, we have the base of a right triangle is 2 meters greater than the height. So let's draw a right triangle. A right triangle. What is a right triangle? You know, when you don't know the meaning of some concepts or some objects in mathematics, you have to look them up. Okay. So what is a right triangle? It's a triangle that has a right angle, which is an angle of 90 degrees. Okay. It's a very special type of triangle. And we know that its base, one more time, I'm gonna call this side the base, and this is obviously the height, like so. We know that the base is 2 meters greater than the height. So that's the way I can represent that. And we know the area of the triangle is 100 meters squared. So the area is 100 meters squared. What are the dimensions of the base and height? Well, this is pretty much the same problem as before. The fact that they are telling us that this is a right triangle makes no difference. It doesn't make any difference whatsoever. The area is base times height over 2, and therefore the area, being 100, will be equal to the base, which is h plus 2 times h over 2, and you have to do exactly the same to find the base and the height. So that's it, guys. How much time did that take us? About 11 minutes. You see, it's quite simple. I think you can solve this whole portfolio in about half hour, maybe. So yeah, that's it, guys. If you have more questions about any other, by the way, remember, I'm trying to check out what problems in the PIA and what problems in the portfolio number 4 uh, are especially difficult, and I'm gonna have to do something about that. Okay, if I think there are many problems like that, I'm gonna have to do something to that respect. If there are some few problems, I may not do anything, because anyways the grade for Math Excel is not that high, so I may as well not change anything. Okay, so that's about it, guys. Thank you.